Hello viewers, welcome to the video lecture series of the job role Soil and Water Testing Lab Assistant for Class 11, Unit 1, Introduction to the Soils, Session 4. In the previous session, that is Session 3, we have seen about physical properties of soil like color, texture, structure, soil bulk density, particle density and its calculations. Student, today under Session 4, we are going to learn about some physical properties which includes soil aggregation, moisture content, saturation, field capacity and permanent wilting point. So student, let's begin our today's lecture with soil aggregation. Viewers, on the earth crust, primary soil particles of sand, silt and clay are united together to form the secondary soil particles. These secondary soil particles are called as soil aggregates or beds. In pedology, aggregate stability is an important indicator of the soil physical quality. Greater stability supports the resistant nature of the soil to water erosion, while unstable aggregate will disperse frequently during precipitation. Typically, the soil aggregates are classified as: first is clay aggregates with size less than 2 micron, micro aggregates with size in between 2 to 250 micron, macro aggregates with soil more than 250 micron. Student, the next important physical property is moisture content of the soil. It is actually the amount of the water which is present in the soil, and it is expressed as the amount of the water per unit mass or volume of soil. Student, let us suppose when 150 millimeter of the water is present in a depth of 1 meter deep soil, then the soil moisture content we called as a 150 millimeters per meter. Viewers, this is actually the volumetric representation of the moisture content in the soil. The soil moisture content can also be expressed on a weight by weight basis. Student, next property on line is moisture retention. It is one of the most important physical properties which is related to the irrigations of the crops. Typically, the moisture retention capacity is the potential of a soil to hold the water. Such potential is basically based on the saturation, field capacity and permanent wilting point. Student, now let us look one by one into detail. First is saturation. Saturation is the maximum potential of the soil to hold back the water or maximum water holding capacity. It is a condition when no air is left in the soil in a saturation point. Student, you know that the saturation of the water depends upon the soil types. Like for the clay, it can hold the water for 2 to 3 days, while the sand is unable to hold the water for the longer duration and drain off only in a few hours. Student, now next is the field capacity, which can be understood through following points. Viewers, it is a condition of the soil in which the larger soil pores are still filled with both air and water, while the smaller pores are still full of water. At field capacity, the water and the air content of the soil are considered as ideal for the crop growth. The field capacity of the soil is dependent upon the soil texture. The time needed to reach the field capacity in a soil is affected by its texture. The field capacity in the sandy soil is reached in 1 to 2 days, and in clay soil it takes about a week. Student, it is interesting to know that the volumetric soil moisture content retained at field capacity is about 10 to 18% for sandy soil, 20 to 32% for loam soil, and 36 to 42% for clay soil. Student, now let us learn about the permanent wilting point. Viewers, when the soil has reached its field capacity, the water which is present in the soil is used up gradually by the process of evapotranspiration. If no addition of the water is done, then the plant starts to wilt, leading to die. Particular stage of the soil is known as permanent wilting point. So student, coming to the end of the video, let us summarize what we have learned today. First, we had seen the soil aggregation, the process by which the group of the soil particles bind to each other more strongly than to the adjacent particles. Second, we have learned briefly about moisture content, that is, finite amount of water in soil. Next, we have studied saturation, which is the maximum potential of the soil to hold water. Then come to the field capacity. This condition of the soil in which the larger soil pores are still filled with both air and water, while the smaller pores are still full of water. Finally, we have seen the permanent wilting point, which is the minimum amount of the water in the soil that plant required not to wilt. So student, that's all for this session. Till then, keep watching and enjoy learning. Thank you.